From the Alaskan wilderness to the swamps of Apalachicola, from the Rocky Mountains to the Arizona desert, America's national forests are home to some of the most biologically diverse and economically important landscapes in the world. These ecosystems are under the management of the USDA Forest Service. About 200,000 miles of rivers and streams wind through this terrain. Waterways are critical habitat for fish and other aquatic organisms. But for every mile of waterway, there are nearly 2 miles of roads. And where the roads and waterways intersect, there are culverts and problems. Many of these stream crossings now function as dams that prevent the passage of fish and other organisms. The challenge for forest managers is to find ways to break the barriers in these critical habitats. For aquatic life, survival is literally a matter of getting across.
Everywhere we've looked, at every National Forest unit, we have found problems. Usually we'll go to a forest or look and people aren't even aware of some of the problems.
We used to look at road stream crossings as basically an engineering problem. Today, however, though, it's the health and diversity of our watersheds is the issue, and we're really needing to look at it from an interdisciplinary approach, using the best science as we move through this.
On the Ouachita National Forest in Arkansas, Forest Service biologists Mel Warren and Rich Standage are checking to see if repairing a stream crossing has restored the habitat for some of these fish.
How you doing, Rich?
Fine. Rolled a couple darters, so we've definitely got them in here where we didn't have them before we fixed the culvert. So it's working.
They've found that about half of the stream crossings here are accidental barriers to passage. But with this one repaired, there's one less barrier.
And the fish can utilize it now where they had been cut off for maybe 20 years before of not being able to make it up into that tributary to spawn.
Streams like these have little or no game fish. But many think that aquatic passage at this level is a priority, despite limited funding.
In my estimation, we're not doing anything close to what we could be doing and we should be doing for these crossings.
Well, in North America, we have over 800 species of fishes. Most of these are non-game fishes. The majority, well over 2/3, are non-game fishes. Many of these non-game fishes are affected by barriers to passage, and all these fishes function there to help process matter in the streams, and on the downstream end to help produce productive fisheries for the sport fishermen.
About 1/3 of non-game fish are threatened, endangered, or of special concern. These fish share ecosystems in complex ways with other creatures, such as mussels.
A mussel the size of your hand can filter about 1/4 of water per hour. They're sedentary animals. The only way they can disperse is by means of the fishes on which their larvae live for a brief period before they metamorphose into adult mussels. So most of their movement is concentrated in this larval stage as they hitchhike on fishes. And so barriers to passage could limit the distribution of freshwater mussels in stream systems simply by limiting the fishes that are able to cross through those barriers.
Nearly 3/4 of North America's mussels are threatened, endangered, or of special concern. Almost half of the native crayfish are in the same situation. The highest concentration of aquatic species at risk is in the southeast, but all regions of the country are affected. And nearly 70% of these at-risk species are in the national forests.
As a matter of fact, most of the species that are threatened, endangered, or sensitive occur in streams that from medium-sized rivers to these headwaters.
Aquatic organisms need access to places that provide escape from unfavorable conditions, like high or low flows or temperature shifts.
They'll move upstream to find desirable spawning habitats. Certain fish in any species tend to be pioneers and move into new waters to utilize new habitats. It's also to get to new food sources, to escape predation.
In Montana's Lolo National Forest, engineer and hydrologist Tracy Silty studies the movement of aquatic species.
Research tells us that adult trout can swim for long distances at 1 to 3 feet per second. Now the dace species, even at maximum speeds, can only sustain 1 to 2 feet per second. So the swimming capabilities of different species can be very different, and this is a very important consideration.
Aquatic organisms evolved under certain water velocities and flow depths. When these conditions change markedly, species can be stressed or killed.
Standard culverts function much differently than the streams that they become part of. The water velocities inside of culverts often exceed the swimming capabilities of most adult trout and typically are far beyond what most juveniles can sustain. During dry seasons, the depths within the culvert can become so shallow that most aquatic organisms can't get through the pipe. Under natural conditions, the irregularities along the stream margins, the bottom and the sides, create slow velocity areas and resting places for fish and other aquatic organisms during storm events. And then when flows go low, they create little passageways. The big question with all of this is, how do we duplicate the stream through the road crossing?
In the Falls Creek drainage of Alaska's Tongass National Forest, Tracy Silty has teamed up with hydrologist Mike Furness to inventory crossing problems.
Historically, crossings were about providing safe travel and sometimes passage for adult anadromous fish. And we didn't pay a lot of attention to the juvenile life stage, to other species, to stream processes or watershed linkages.
Stream crossings first became an issue for the Forest Service in the days of steam locomotives, but the number of crossings has grown dramatically since the automobile.
The engineer's toolkit for crossings that weren't bridges consisted of steel and aluminum culverts, sometimes corrugated, sometimes not, concrete low water crossings, concrete box culverts, and going back to the old railroad days, culverts made out of wood.
Over time, perspectives on stream crossings and the aquatic creatures that depend on them have changed.
Over the years, we've learned a great deal about engineering and hydrology and biology. And we now understand why these organisms need to move and how to provide for that in our designs.
Mike Furness helped develop Fish Crossing, a software tool to test whether fish can pass through the expected range of flows in a culvert when other, more expensive solutions are impractical.
The best way is usually a bridge, but often a bridge isn't feasible. And where it isn't, the best solution is what we call stream simulation. And we do that by matching the width and the gradient and the stream bottom to what we find in the stream, so that we have a seamless connection between the stream and the culvert. And to an aquatic organism, the culvert, the crossing, looks just the same as the stream does.
In the short term, simulated culverts cost more than standard culverts, but over their design life, they actually save time and money because they reduce the maintenance costs associated with chronic problems and total failures. They're also sized properly for flood events, which optimizes road safety and minimizes erosion and sedimentation to the streams.
Culverts can cause what are known as backwater effects at the inlet. They can allow debris and sediment to deposit, eventually plugging the culvert. This can cause a domino effect of crossings that fail during large storm events, washing out roads and adding more sediment to streams. There are also significant hidden costs of poorly designed crossings.
When you start adding up how much of the watershed is functionally cut off to aquatic organisms, the importance of providing passage is clear. Well, obviously we can't fix all the problems at once, and so we'll have to set priorities. Now, culverts have a lifespan of 25 to 30 years, so there'll be plenty of opportunities to replace with passable structures as we go. But we'll have to make sure, particularly away from the arterial roads and in the upper reaches of watersheds, that we don't miss something that needs immediate attention. We can't afford to have a barrier accidentally isolating a genetically distinct population, increasing the risk of extinction.
Extinction is a major concern in the Pacific Northwest, where most clusters of at-risk salmon, steelhead, and sea-run cutthroat are found. In the Loxa-Selway drainage of the Clearwater National Forest, a multidisciplinary team is taking on problem crossings.
The majority of our spawning and rearing habitats for salmon, steelhead, resident trout occur in the smaller tributaries of the larger streams. And basically by eliminating the barriers that we have, namely culverts, we can increase habitat access to those habitats exponentially. The Badger Creek culvert has actually been known to be a barrier since 1979, when one of the original Clearwater National Forest fish biologists identified it as a problem. Badger Creek feeds into the Loxa River. The Loxa River feeds into the Clearwater River. The Clearwater feeds into the Snake and eventually into the Columbia River. So the fish populations that we have here are part of the big Columbia River Basin. What we do here can affect populations overall.
From the beginning to the end of construction, the entire project took approximately 6 months. The Idaho Transportation Department paid for the installation of these culverts. The Forest Service identified the problem and assisted with design and permitting. The Nez Perce tribe assisted with engineering and funding for the project.
This area that we're in right now is an Aboriginal territory for the Nez Perce tribe. And the Nez Perce tribe has hunting and fishing treaty rights in this area. And in order for those rights to be meaningful, we have to have healthy populations of wildlife, we have to have healthy populations of fish. And so we approached the Forest Service on working collaboratively on restoration activities.
1 year after restoring passage, this partnership is paying off.
I did a spawning survey up the stream and found evidence of bull trout spawning, which hadn't been seen in a while, for about 50 years. And just last spring, 2 steelhead were actually seen in the creek spawning. So that was great.
Repairing barrier crossings is now a group effort across the country. Forest Service personnel are joining with other federal and state agencies, with tribes, local highway departments, conservation groups, landowners, and others to do this important work.
Mobilizing our resources to address passage barriers, really to sew the landscape back together, crossing by crossing, ought to be a priority at every level of the agency. Under the Endangered Species and Clean Water Acts, we're responsible for ensuring free passage of native aquatic species in the waterways of the National Forest System. Not only is it the right thing to do, but I believe we face substantial biological, legal, and credibility risks if we fail to redeem our stewardship responsibilities to these resources.
These access corridors, they're the true wealth of our nation. That's how we provide the standard of living that is so important to Americans. Along with that standard of living and the quality of life, though, is our interrelationship with our environment. And Americans want to have that relationship with the out of doors. They want to protect other species. They want that quality of life.